In this video, we'll understand the concept of triangles. Now, before going to the concept of triangles, let's just revise a few things that we have studied in the previous years. So, triangle is a three-sided polygon. It has got three angles, that is A, B, and C. The vertices are the angles A, B, and C, and AB, BC, and CA are the three sides of triangle. So, basically, we have three angles and three sides in a triangle. Now, always remember, if there is a triangle ABC and if AB is equal to AC, then angles opposite to equal sides are equal, which means angle C will be equal to angle B. And vice versa is also true. So conversely, if angle B and angle C are equal, then sides opposite to equal angles are also equal. So we will say AC is equal to AB. Now, in case the sides are not equal, but one is larger, one is smaller. So, for example, if I have a triangle ABC here and AB is more than AC, so angle opposite to AB, that is angle C, will also be more than angle B. So, if for the equal sides and for the unequal sides, this is the relation that you should know. Now let's take some of the terminologies that we will use in this chapter. So first is median. Median is something, for example, if I have a line from A to BC and it touches at D here, and if I say AD is the median, so if AD is the median, that means it will divide BC in two equal parts, which means this will be equal to this. It does not say it will be perpendicular or it will make 90 degrees. It is just saying it will divide it in two equal parts. Second is altitude. Now kids often get confused with altitude and perpendicular bisector. So both are entirely different. In case of altitude, altitude will just make 90 degrees. It will not divide BC into equal parts. It will just make an angle of 90 degrees. But a perpendicular bisector will make an angle of 90 as well as will divide BC into equal parts. So basically, perpendicular bisector is the combination of median and altitude. It will be 90 also and it will divide BC, this BC part into equal parts. So I can say BD is equal to CD in case of perpendicular bisector. Now let us understand the main part of the chapter, which is congruency. Now what is congruency? So congruency is when we have two figures which are exactly identical. Like for example, if I put my two hands like that and if I can't see the other one, so basically they are superimposed on each other, such figures are known as congruent figures. So we will deal with congruent triangles in this chapter, and there are 5 criteria in which we can prove the triangles to be congruent. As we discussed earlier, a triangle has got 6 features, so 3 angles and 3 sides. So we will use, out of these 6, we will use 3 of them to prove the triangles to be congruent. The first one is side angle side. Now in side angle side, what happens is we have two triangles ABC and PQR. So for example, if AB is equal to PQ, angle A is equal to angle P, and AC is equal to PR. So in this case, I can apply side angle side. Now remember here, the angle has to be in between the sides. So I can't use this angle and this angle. It has to be the angle between the congruent or between the equal sides. So because my AB is equal to PQ, AC is equal to PR, so my angle has to be this one only. So I can say triangle ABC is congruent to triangle PQR. Now remember one more thing here, whatever is congruent to each other, for example, here AB is equal to PQ. So they should appear in the respective order here. So I can see AB here, so PQ is equal to here. AC here, so AC and PR. So this order has to be maintained. this angle A is equal to angle P, so my A and P are together. So this is your criteria SAS or side angle side. Now we used the three given things which were already given to us. Based on this congruency, we can prove the remaining three parts. Like for example, the remaining one side, that is BC is equal to QR. It was not given to us, but after congruency, we can prove that BC is equal to QR, angle B is equal to angle Q, and angle C is equal to angle R. These three conditions that we derived after proving congruency are, we term it as CPCTC in ICSE and CPCT in CBSE. Both mean the same, that is corresponding parts of congruent triangles are congruent, or corresponding parts of congruent triangles are equal. Both mean the same. So out of 6, 3 are given to us, 3 we derive, and this is how we prove any question in the whatever is given to you. Let's go for second criteria, which is side, side, side. As it explains, all the sides have to be equal. So AB is equal to B. Let's just twist this time. So AB is equal to QR, let's say. BC is equal to PQ and AC is equal to PR. So because all my sides are equal, this is equal to this is equal to this, and this is equal to this. So now these triangles are congruent based on side, side, side congruency, or SSS. Now how do we write this one? Triangle ABC. Now AB corresponds to QR here. So I will not start with P because AB corresponds to Q. So let's say AB is corresponding to QR. So let me just write QRP. Now let's take the other ones. BC is equal to PQ. So does it look like BC is equal to PQ? No, it doesn't. So what we'll do is we'll make it RQ. So now let's check. AB is equal to QR. So yes, AB is equal to RQ and QR are same. BC is equal to PQ. So BC is equal to PQ again. QP and PQ are same. And AC, which is AC is equal to PR, again satisfies. So in this way, you have to write the congruent triangles based on their respective positions. So based on that, you can say angle A is equal to angle R, angle B is equal to angle Q, and angle C is equal to angle P by CPCTC or CPCT. Let's go for the third criteria, which is ASA, that is angle side angle. So as the name says, let's say if angle B is equal to angle Q, angle A is equal to angle P, and now if I have to choose a side which is in between these two angles. I can't choose the other two sides. So AB is equal to PQ. So now I can say by angle side angle, or ASA, triangles are congruent. Fourth criteria is angle, angle side. So as the name says, let's say angle, this is equal to this, angle, this is equal to this. Now you can't choose BC as the side because the other side has to be not included between the angles. So it can be this, it can be this, it can be this, it can be this. Anything is fine. So let's say this is equal to this. So this is my angle, angle side. The side does not have to include between the angles. Now a very important thing here, most of the kids get confused because we have ASA, because we have AAS, kids get confused with a congruency ASS. They often apply ASS as the congruency. There is no congruency like this. So do not apply, do not get into flow of side, angle side, angle side, angle, angle, angle side, because we have these three. Also they assume ASS has to be a congruency. There is no congruency like that. The last one is RHS. Now RHS congruency is applicable only for right angled triangles. You cannot apply this congruency in your regular triangles. The triangle has to be a right angled triangle. So as the name says, RHS, it means right angle hypotenuse side. So of course right angles means right angle here. So B is equal to Q. Hypotenuse, the angle opposite to 90 is your hypotenuse. So AC is equal to PR. So these has to be the fixed thing. So angle B, that is my 90 degrees, and the hypotenuse are fixed. Now you can choose any side. So I can have this side and this side also as equal. So RHS is right angle hypotenuse side. So right angle has to be the same. Hypotenuse, both hypotenuse have to be same, and any of the sides, if they satisfy the criteria, then we can say RHS is applied and triangles are congruent. So this is how you can apply these 5 congruency criteria to your questions and get the answer. We'll take up a few questions to understand these concepts better. Now let us say a question to understand this concept better. So we have a question here in triangle ABC, D is the midpoint of BC. AD is produced to E so that DE is equal to AD. So based on the given question, we are supposed to draw the diagram if it is not given to you. So we have a triangle ABC here. This D is the midpoint of BC and we produce this AD to E so that this AD is equal to DE. So we join this EC. Now, first of all, the first thing you do in the question is write given to prove. Before you start the proof, you're supposed to draw the diagram, write the given things, write to prove, and then we'll go for the proof. Even if you don't know the question, even if you can't attempt it, at least draw the figure and write the given and to prove. This also carries marks. So let's go to the proof now. Now, in this, the question becomes more simpler when you identify what you are supposed to prove. Here we are supposed to prove triangle ABD is congruent. So ABD, this triangle is congruent to triangle DCE. So what we'll do is we'll take them directly. So prove in triangle ABD and triangle ECD. My works gets very simpler when I identify what I'm supposed to prove. And if you draw the diagram well, half of the problems are solved. Now, here we are given that BD is equal to CD. You have to write the reason for that, so it is given. Second part, I can say angle 1 is equal to angle 2 because they are vertically opposite angles. Now, how to identify vertically opposite angles? If two angles make an X, so if they cross like that, see they are making an X. So if they are crossing like that, so you can identify them as vertically opposite angles. So I can say here angle 1 is equal to angle 2, vertically opposite angles. We need a third criteria also, which is given to us as AD is equal to DE, again given. So I have got the 3 criteria here. So I will say therefore triangle ABD is congruent to triangle ECD by side angle side. So SAS congruency. The triangles are congruent. So my first part of the question is proved. Now based on this congruency, I can derive things like AB is equal to EC by CPCTC or CPCT. So my second part is also proved, AB is equal to AC. So my first part is proved, second part is proved. I can also identify here that this angle is equal to this angle. If you see here, angle B should be equal to angle C by CPCT again. So I will write angle 3 is equal to angle 4. Now if you look this properly, they are forming a Z like this. So if you see two angles forming a Z like this, they are also alternate angles. So when the angles are alternate, we can say the lines are parallel. Now because my 3 and 4 are equal, also they are alternate angles. So we can say that AB is parallel to EC. So this is how we prove all the 3 things which are given to you in the question. This question can be asked for 3 to 4 marks and it's a very simple question. So a simple catch here is to identify which triangles to prove congruent, what congruency to be applied here, and based on that The other results can easily be, get you with the help of CPCT. Let us take one more question to understand this concept better. So we have from the given figure in which ABC is a parallelogram, ABL is a line segment, and E is the midpoint of BC. So in this case now, the figure is given to you. In the previous one, we had just we had to draw the figure based on the question. So here figure is given to us where E is the midpoint. So basically CE is equal to BE, and ABCD is a parallelogram. So CD is parallel to AB, and hence because L is the extension here, so CD is also parallel to AL. We are supposed to prove that DCE, triangle DCE, so this triangle is congruent to triangle LBE, so this triangle. So let's get started with this. In triangle DCE, and triangle LBE, I can say angle C, this angle 1 is equal to angle 2, because CD is parallel to BL, CD is parallel to AB and BC is the transversal. So 1 and 2 are the alternate angles here. So I can say angle 1 is equal to angle 2, alternate angles. BE is equal to EC, that is given to us. And angle 3 is equal to angle 4, because they are vertically opposite angles. Here you can also use this and this angle, because the CD and AL are parallel and DL is the transversal, so you can apply this and this also. Completely your choice. This question can be done with two congruencies. So I can say, therefore triangle DCE is congruent to triangle LBE. Now I have used here angle, side, angle. You can also go for angle, angle, side, completely your choice. So I am using here ASA congruency. So my triangles are congruent from angle, side, angle congruency. So based on this, I can say that CD is equal to BL, CPCTC. So my first part is proved here. Second part, I am supposed to prove AB is equal to BL. Now because ABCD is a parallelogram, AB is already equal to CD. So I will write here, since ABCD is a parallelogram, therefore we can say AB is equal to CD. Opposite sides of parallelogram are equal. Now AB is equal to CD and CD is equal to BL. So from these two, we can say that AB is equal to BL. From this and this, we can say that AB is equal to BL. Now remember, in geometry, you are supposed to write these reasons. These reasons are very, very important. You get marks for that. So AB is equal to BL. This proves my second to prove part as well. The third part is AL is equal to twice of CD. Now if we see that here, AL is equal to AB plus BL. Now AB is equal to, we have already seen here, AB is equal to CD. So instead of AB, I will write CD. Instead of BL also, I can write CD. So I get AB is equal to twice of CD, which is what is my third subpart of the question. So based on the given questions, we just have to prove them congruent, and we can derive the remaining parts as CPCTC, or you can just twist and a little question and you can get the all subparts. So it is not as difficult as you think of. I hope you found this video useful today, and you can practice more questions based on the concept that we have studied today.